You ready, Martin?
Yes.
Okay.
In this presentation, we will be analyzing social sentiment data to determine its correlation with cryptocurrency price. Presenting today, we have Ripa Shah, Karthikeyan Manikan, and Martin Layson. The research is aimed at understanding how public mood can fluctuate the cryptocurrency volatile market. Historical and live Reddit sentiment data for 5 major cryptocurrencies were collected and cross-referenced with Yahoo Finance price data. We will explore this with two different approaches. In Module 1, we will use Apify API focusing on Solana, and on Module 2, we'll be leveraging Azure's Cosmos DB and PySparks for the other cryptocurrencies.
Python code was utilized to gather data utilizing the Apify API, which utilized the Reddit API, which provided us the data on sentiment. Price was aggregated from the date timestamp to open and close price per day for 365 days. Sentiment was analyzed in Python with sentiment already output from the Apify API, and additional sentiment analysis was added in Python through Vader analysis, Vader sentiment analysis. The differentiator for determining correlation accuracy from sentiment to price in current month was volume of sentiment data versus classification of sentiment data. Example, the month with the highest volume correlated to the highest price of Solana, and the months which had the lowest volume correlated to the lowest price on Solana. However, sentiment data was an accurate predictor of subsequent changes in price in the following months.
Some of the challenges that we encountered include using Apify API required continuous payment. We, however, successfully leveraged the API to gather sentiment data from relevant cryptocurrency communities on Reddit, ensuring continuous data flow. Another challenge was to meet the demands of big data technology and dynamic reporting. Custom APIs were developed in Python using Grok and Flask, complete with secure tunneling and authentication, allowing us to leverage a web front end to display information graphically.
This is module 2, and this module is regarding Reddit API and Yahoo Finance prices. So we collected sentiment data and price data and stored those records into the Cosmos DB database by implementing a Python script. Once we had 12 months of historical and live data, we converted those records from Azure Cosmos DB to PySpark. And by using 3 main machine learning algorithms, we train sentiment score to forecast crypto prices for next 3 months. So first of all, data quality. So analyze the rigorous cleaning and exploratory data analysis that is crucial for data analysis and machine learning algorithm. Second is sentiment relationship. Correlate previous day sentiment, current day sentiment, and next day sentiment with price to understand influence of public mood and cryptocurrency fluctuation. Storage solution. Uh, so uh, provide a comparative analysis of data storage solution. Uh, Between Azure Cosmos DB and CSV file and optimal forecasting algorithm. In this one, we have forecast algorithm for Bitcoin and Ethereum, price movements using advanced machine learning algorithm, which are SVM and LSTM. Azure Cosmos DB, why it matters. So global distribution. So Azure Cosmos DB has a multi-region write capabilities and automatic geo-replication, allowing application to serve customer worldwide with low latency. CSV files are limited to specific storage places. And automatic indexing, which is which improves query performance. So for example, in this project for the crypto price data container, I have utilized composite key, and which is beneficial for removing duplicate from that container. Project architecture. So my project architecture consists of Reddit API, Yahoo Finance, Azure Cosmos DB, and PySpark. So first of all, I have created account in Reddit, and then I have by this way I'm able to retrieve client ID, client secret, and user agent information, and from then once I have those data ready, I have integrate those data into the Reddit Python script, and uh, similarly for the Cosmos DB, I have created account into the Cosmos DB database and also resource group. Once it is deployed, I have created database, and followingly I have also created a container. Uh, so database name is Reddit Crypto, and container names are Crypto Price and Reddit Sentiment. So by implementing containers, I am able to use database ID and container ID along with key and URI in Python script, and I am able to connect with Cosmos DB database. And after that, I am able to insert the records into Cosmos DB database using Reddit API and Yahoo Finance API. And once it's gathered data, I am able to convert those data into PySpark data frame. And once it's done, I have assigned the schema, and I perform the data cleaning, data exploratory analysis. And after that, I have implemented machine learning algorithm and also forecast the price. In the data pre-processing and cleaning, first of all, as I mentioned earlier, I have converted Azure Cosmos DB data into the PySpark data frame, and right after that, I have assigned a schema, and then I have also augment or merge the fields by by and also I have renamed the fields. For example, in feature engineering, I have done named the timestamp to date in crypto price data set to facilitate seamless join with Reddit sentiment data set. Applied filter transformation on sentiment score to classify data as neutral, positive, or negative, and retrieve only cryptocurrency abbreviation from symbol field in crypto price dataset, and rename it to cryptocurrency field and remove symbol field. In data cleaning process, I do not need to remove duplicates from crypto price dataset since I have composite key. I have duplicates in Reddit sentiment dataset, so I have removed duplicates. Then I have implemented mean imputation on sentiment score field. After that, I have assigned missing keyword on string values, and also verify whether does it have any null values on date field or not. Also, I have removed inessential cryptocurrency values. Uh, in exploratory data analysis, I have performed various statistical graphs. From that, I have also performed distribution analysis that reveal that highest number of positive sentiments overall, and data set contains mildly negative, neutral, and positive sentiment ranging from minus 0.5 to 0.25. And sentiment distribution by cryptocurrency, which is a box plot. And in this one, I am seeing outlier for Ethereum and Solana, and the median for this box plot is approximately 40 or 41 for all the cryptocurrencies. Uh, Total reviews by cryptocurrency graph. In this graph, I am seeing more positive for Bitcoin and Ethereum, and also more negative for Bitcoin and Ethereum, and more neutral for Dogecoin. And I have also performed the count analysis for unique users. So I'm seeing around uh, maximum number for Bitcoin and Ethereum uh, for count analysis. Then I have implemented time series analysis. In this one, previous day sentiment exhibits a stronger correlation with cryptocurrency price fluctuation compared to current day sentiment, and similarly, next day sentiment also exhibit correlation with cryptocurrency price, though the relation is less direct. Here in this figure, demonstrating previous day sentiment versus current day price for Bitcoin, and current day price versus next day sentiment for Bitcoin. And I have also analyzed for Ethereum. You can check my project report for that. In correlation coefficient, this is a heat map for Bitcoin. The first diagram is for Bitcoin and second diagram is for Ethereum. So I'm seeing the positive correlation between previous day sentiment and average price, and negative correlation or weak correlation with uh, previous day sentiment with average price, and average sentiment with average price. So after that, I have performed three main algorithms. First is the random forest. For the data scaling, I have used min-max scaler for all of them. And for model performance, and also I have utilized the time series split, which is a k-fold variation of k-fold technique, and it is a real world, it is good for real world forecasting. And I have for Bitcoin, I got 51% average accuracy, and for Ethereum, I got 64% average accuracy. Similarly, for LSTM, I got around 68% overall accuracy for Bitcoin and 67% overall accuracy for Ethereum. And for SVM, I got 68% overall accuracy, and for Ethereum, I got 70% overall accuracy. Here is the forecast for 3-month price for LSTM and SVM. This is for Bitcoin. So I'm seeing that SVM is performing better than LSTM. And similarly for Ethereum, SVM is also performing better than LSTM. And the key takeaways are: volume of sentiment data is stronger predictor of cryptocurrency price movement. Previous day sentiment shows stronger correlation than current day sentiment. LSTM and SVM models achieved 70% accuracy for Bitcoin price direction. Azure Cosmos DB provides superior scalability and performance over CSV storage. Rigorous data cleaning and pre-processing are critical for model accuracy. So I have implemented this project in CSV format, and after that I have just migrated to Azure Cosmos DB, and it was difficult while installing a Maven jar file, and it took me a while to figure it out. Another challenge was Google Colab. Google Colab always have a dynamic IP address, and that was uh, also tricky. So I have assigned a public IP address in my network configuration of Azure Cosmos DB and resolve this issue. I have learned PySpark from scratch, and I implemented time series split to fix random sampling and stratified k-fold failures in random forest algorithm, and optimized scalars and day splits to achieve 70% algorithm accuracy in LSTM and SVM. So I have already tried min standard scaler, but it wasn't giving a good performance than min max scaler. And I also tried various dates uh, to achieve performance, and that was our project. Thank you so much uh, for listening. Any question?